Hello students, I am Dr. Sunita, Assistant Professor, Government Nagarjuna PG Science College, Raipur. And this is the video second for the MSc 4th semester students, paper 3rd and unit 1. In the previous video, we have studied the structure reactivity relationship. Now in this video, we will going to discuss a very important topic, that is Hammett plot and Hammett equation. The influence of the functional group. What we have studied here, the substituent will affect the rate of the reaction. That was the structure reactivity relationship. Now the influence of the functional group on the course of the reaction shows uniform pattern, that is a qualitative in nature. And for the quantification of this pattern, we need an empirical relation. And the development of means by which one body of the data can be related to another is called empirical correlation. Empirical correlation of the reactivities of organic compound are often linear relationship involving logarithms of rate constant or equilibrium constant. That means that is an Hammett plot is an empirical correlation of reactivities of organic compound that are linear relations involving rate constant or equilibrium constant. Okay. How? Let us see an example. We are taking acid here. With H2O. So this will become like here this H2 will attack at this position and this OH will come out this. Similarly, this is a negative charge center, so the electron withdrawing group will increase the rate of the reaction, while the electron donating group will decrease the reaction. And this can be plotted on a plot where we have log K, logarithm of the rate constant on the y-axis, log K for ethyl benzoate, and this is log K for benzoic acid. Here we are using the substituted benzoic acid, and here we are using the dissociation of the benzoic acid. Now here we got something like this, where this is paranitro, this is metanitro, this is MCl, this is paraCl, and this is for H, this is for metamethyl, this is for paramethyl, this is for methoxy, this is for ortho. Somewhere here we got for OMe, ortho. Here we have ortho NO2. So when the values of the log K for the hydrolysis of the ethyl benzoate is plotted against the log K for the benzoic acid, we got a plot like this, where only the values of meta and para is falling on the straight line, ortho things are getting out of the line. And we are soon going to discuss the reason why this is not falling on the line. And the values are very clear. When we have the negative center, rate will be high. So the rate is nitro is the highest, have the highest electron withdrawing tendency, so it becomes the higher. Meta becomes less, then becomes the chloro. Okay, so this trend is due to that table which we have discussed. Electron withdrawing, more electron withdrawing will stabilize the transition state. So here we got this equation from this plot. We got this equation: log of the rate constant is equals to rho log of the equilibrium constant plus constant C. Now with this, it is very clear that Hammett relationship applies only to the system where the substituents are attached either to the meta position or to the para position. Either to the meta or the para. Ortho will not fall on the line, and the reason is due to the steric hindrance, because more crowding will be there in the tetrahedral intermediate. Similarly, it is not for the aliphatic acids. Aliphatic acids also do not follow the Hammett plot, Hammett equation, nothing, because that is a very flexible entity and the transition structure will get more complex, more steric crowding is there, and there is a less correlation between the transition state structure and equilibrium position. So the values are not for this Hammett plot is not applicable for Hammett relationship is not applicable for ortho substituents and aliphatic acids. Now we again come to the Hammett equation. Now Hammett recognized that electronic influence of a substituent X on the reaction center. If suppose we have this ortho, this is para and this is meta. Now electronic influence of substituent X on reaction center. This may be assessed by studying the reaction in meta and para substituted benzene derivative. Quantitatively, the electronic effect of each substituent relative to hydrogens may be obtained by comparison of delta G for the dissociation constant of substituted benzoic acid and that with the unsubstituted benzoic acid. For example, if we have a substituted substituent effect, if we are going to see substituent, then it is the minus delta Gx plus delta Gh is equals to log Kx minus log Kh, and this is equal to sigma x. This can be written as log Kx over Kh is equals to sigma x, where this sigma x is very important, known as substituent constant. And electron withdrawing groups are therefore characterized by positive sigma x, and electron donating groups were characterized by negative sigma x. Reason is similar. The things which are enhancing the rate, the groups which are enhancing the rate, they will be shown by the sigma x or sigma positive and sigma negative, that will be stable at the transition state. Decrease the rate will be characterized by sigma negative. So all electron withdrawing groups comes under sigma plus, and electron donating groups will come for sigma negative. So now we come to the substituent constant. When we are now substitutes, there is some characteristic of substituent constant, which is shown by sigma. It is given for the para and the meta only, not for ortho or aliphatic. It is a collective measure of, sigma is the collective measure of the resonance and inductive effect. That is the summation of total electronic effect. Electronic constitutes the resonance and the inductive effect. Now, if we see the para substituted C double bond O, O negative, and suppose we have some X here, and if we have this thing, here plus I is more due to the proximity of the groups. So sigma M is more than sigma P. But here the stabilization is more because the electron is going, electron withdrawing nature is reaching ultimately to the negative side. If we see the bond delocalization, then we see it will go like this. It will go like this. So there is this sigma P is more than sigma M. So sigma is the collective effect of the electronic effects consisting of the resonance and the inductive, and it is independent of the reaction center. Nature of the reaction site does not affect the sigma. Okay, so these are some characteristic of the substitution constant. So we will stop the video here, and in the next video we will discuss the derivation of the Hammett equation.